like this. This is not a problem for which, here's the formula to discover that is, no, I got nothing like that. I got nothing like that. All I have are functions that work in right triangles. That's all I've got. So I'm hoping that they gave me enough information so I can set up some equations, right? Now, real quick, again, here's the building he's in, here's the building he's looking at. So if he looks 15 degrees up, that's what angle of elevation means. If he looks 15 degrees up, he sees the top of the building. If he looks 2 degrees down, angle of depression, he sees the bottom of the building. So everybody should be able to draw that picture given that description. What do you do next? You look for right triangles. Right? So I found 2 right triangles. And why are they good? Because this is the question, and that's in both of them. This is what I know something about, and that's in both of them. Right? So which variable is that we've set up? Because you can make the variables anything you want to. I just made it x because it made sense. Right? You can make it a, b, what, I don't care. Well, which variable related to what I set up are they asking me to discover? What do they want me to solve for? What are they asking me for? How far is the person from the monument? Which variable represents how far they are from the monument? X. So I want to solve for x. Do I give a shit about y? Do I care about y? I don't give a shit about y. All right, good. By the way, guys, I'm just trying to show you, it's been forever since I did this problem. I assigned this problem. When I first assigned it, I did it real quick. It's been years, right? So when I look at this problem, I'm like, oh, shit. So I draw the picture and hope to God that I can see. So I don't know if you guys realize, when I do a problem up here, I have no idea at first what's going to happen. I have no idea how to do it. I got some idea, but until I get it drawn, then I can start to see how the things relate. I have no idea, right? So what is it about this picture that's telling me what to do? I see right triangles. Cool. Okay. Let me draw those and hope to God that I see something, right? Right? So the side that they ask me about and the side that they tell me about, they're related through tangent. Because what's tangent's job is to make a ratio of y side to x side. Oh, kick ass. Right? If I would have wanted to know this, I would have used a different trig function. Right? Okay. And that side I don't care about, so that's why it didn't even come into play. Now, I'm trying to solve for x. So what sucks? How many variables are there here? How many variables are in these equations? 2. X and y, yes? There's 2 variables. Can I solve for x and get a number in either one of them? No, I can't. So what do? I got 2. So I got 2 things I don't know. How much information do I have? 2 pieces of information. I should be able to make that into an answer, right? So which letter do you not care about? Y. We don't care about y. The question's asking for x. So can't I solve this for y? Can you solve this for y? How do you solve this for y? One step. How do you get y by itself? One step. Multiply by x, right? Y is being divided by x. How do I get it by itself? Multiply by x. That'll kill the x, right? The y will be by itself, correct? Okay. So latch on to the stuff that you definitely know. Y is this. So we know that's true. Y is that. We know it's true. So what can I put right there? This. Won't I be able to solve for x then? Because I'll just have x's. So it's like a system of equations. Whenever you have more than one variable, but you have more than one equation, use one of the equations to rewrite the other one. So you only have one variable. This is going to happen a decent amount of the time, right? We have two things we don't know, and we have two pieces of information. I can solve one of them for a letter and then plug that into the other one. Can anyone tell me why this equation by itself sucks? Not just because it has tangent, by the way. Why does this equation suck? That's not a problem. If I ask you to solve this equation, can you? No. Can you get a number? Well, how many variables are in this equation? 2. That sucks. It sucks. I can't solve an equation with 2 unknowns. I can't get a number. I can't. Do you guys understand that? If I try to solve for x, I'm going to have x equals stuff y. It's not a number. So what do I do then? I use this to replace y with x stuff. Okay, cool. Now I've got one variable. I can solve it. Right, so now I've got tangent 2 degrees equals 200 minus y, but what is y? X times tangent of 15 over, where'd it go? X. Then solve that equation. Now real quick, why does that equation suck? Where is one of the variables I'm trying to solve for? On the bottom. So how do I remedy that? How do I get it up? Huh?
Multiply?
Yeah, multiply, right? Multiply by x. Okay, that's I've done play, so I'll let you guys finish it up. Okay. So drawing the picture should probably be one of the harder steps. But does everybody understand now? If you see a problem and it says angle of elevation, that is just, if I'm looking straight out at a 30-degree angle of elevation, I look up 30 degrees. That's what that means. If it's angle to depression, I'm looking out and I look down so many degrees. That's all it means. So that's why this is 15-degree angle of elevation, 2-degree angle of depression. That's what those mean. So you're going to see those in the homework.
Do you want to convert the degrees into something?
You don't have to, no. So again, let me bring back something I said earlier. If I'm going to calculate the area of a sector, what does this have to be? What has to be true about this? You can do it. What's got to be true about the angle? I'm calculating the area of a sector or the arc length. Does anyone remember what something has to be true about this? Second? Radians. It's got to be in radians. Why? What's special about radians? Why is radians better?
Because you can actually see that.
It's a physical measurement. Degrees are totally made up shit, right? But if I am saying tangent of an angle, right? In fact, let me do this. A little review. All right, let's see where everybody is. If I ask you what sine of 30 degrees is, let's run over kind of how to do that. Either you just straight up memorize it. You gotta know these. I can't stress enough that you have to know this stuff. Either you straight up memorize it or you do what I do. Can somebody just tell me 30, 60, 45 degree, 0, 90? Can somebody just give me the numbers that could be the answers? I'll give one. 1/2 could be the answer. Can somebody give me another number that could be the answer? We've seen these numbers. 1/2. Rad 2 over 2. Somebody else give me another one. Rad 3 over 2. I love it. And then of course you got 0 and 1 for the extremes, right? Okay, you guys with me? Those are the special kind of numbers related to the angles we memorize. We only memorize trig functions for 0, 30, 45, 60, 90. Why do we do that? Because they show up the most often. Right? Now what do we do if I have tangent of 11.3 degrees? I freaking throw that in the calculator, right? We're not going to memorize 11.1, 11.2, 11.3 degrees. No, we're not. That's insane, right? But we do have to memorize a few. Okay. Can somebody tell me what is sine? I say this in a weird way, and I'm sorry. What is sine like? X or Y? Sine likes Y, right? So where will sine be the biggest? Here or here? 1 or 2? Why? Why will it be the biggest here? Because here it's all y, yes? It's all y here, right? Okay. So if I'm at 30 degrees, am I close to where sine likes it? No, I'm far away, right? I'm far away from the y-axis. I'm really close to the x-axis, so sine should be small. What's the smallest number out of 1/2? Rad 2 over 2, rad 3 over 2. Which one of those is smallest? 1/2, rad 2 over 2, rad 3 over 2. 1/2. Okay, so that's 1/2. Okay. Just trying to give you a way to not have to just flat out memorize stuff. I don't like doing that. I like to know ideas and then build what I need on those ideas. Then I have less to memorize. You can just memorize them if you want to. Totally, feel free, do it. I highly suggest you don't, right? But you can, okay? So what's my point here? The question was, do you have to do something with this? That was the question, right? Does everybody agree this is true? If I go 30 degrees, right? So again, why does this make sense? Because what is sine for 0 degrees? Is there any x piece? I'm sorry. Is there any sine likes y? Is there any y piece here? And what do I mean by that? Okay. So if I'm here at 0 degrees, there I am. If I go to 30 degrees, right? These are all 1 here. Is there a y piece at 30 degrees? Yes. Right? 30 degrees, there's a y piece, right? If I'm at 0 degrees, is there a y piece? No, right? I have made, if I move a little bit, now I got a y piece. Shit, now I got no y piece. I really want this to... So since sine likes y, and there's no y at 0 degrees, sine of 0 degrees is 0. Sine of 30 grows a little bit because the y piece grows a little bit. It's not 0 anymore. It got a little bit bigger. At 45, it's going to get a little bit bigger. Yes? That's when it becomes rad 2 over 2, because now it's a little bit bigger. Okay, and again, we proved each of those triangles. We proved it twice. Right? And now I'm just trying to give you a way to remember how the numbers kind of go, so you can remember these trig values. Okay, now, finally, I'm going to address your question. What's another way to say 30 degrees? 5 or 6. That's also 1/2, because these both mean the same movement, right? These both mean go by this much. Does that make sense? 30 degrees is that much movement. It's just a made-up unit we use, but it means that much movement. Pi over 6 means the same amount of movement. So when you're inside of a trig function, all the trig function cares about is how much did you rotate? And degrees and radians, they both mean rotation. When it's outside on its own, it's got to be a physical measurement to make sense. It can't be degrees. I really want this to make sense. Do you guys remember? Did it have to be 360 degrees in a triangle, in a circle? Remember that? It didn't have, there's nothing special about 360. We just picked it because we can factor it a lot of ways. Do you guys remember that? Do you guys really understand that? We could have picked any freaking number we wanted to. And we just went, oh, 360, okay. Do you really understand what I'm saying there? Nothing special about 360 except that it could be factored, so we liked it. We could have made it 3600. We could have made it 7, right? 7 is not a great choice. Maybe. So, the area can't be dependent on a unit we made up. Because we could have made it up different. If we would have chosen a different thing, would everything have gotten bigger? Suddenly in the world, we say, no, I want 400 degrees. Boom, everything gets bigger. I don't know if you guys are really understanding. Okay. So when it's out on its own, it must be radians, because that's the actual physical measurement. What's a radian again?
Radius along the
Yeah, if I take the radius and I bend it and put it, it's an actual thing, I can hold it. You can give me a circle made out of freaking metal, and I can take the radius and I can bend it up, and I can put it on this, I can see it. Degrees, made up shit, right? So when the angle is on its own, it must be radians. When it's inside of a trig function, it could be either one. Because no matter what I call this angle, it means the same thing. It means rotate this much. So no matter how I call it, it's going to have the same y length. If I rotate this much, it's got a certain y length. I don't care what I call this. Okay, maybe. Okay, that's enough of that. Enough. Okay. Let's see. Blah, 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 blah. Okay. So that one's a pretty good problem, but it's also a pretty basic problem, right? To be honest. Okay. But it's a decent little problem. You just have to draw a lot. Okay. Anything else from homework stuff? Oh, let me get back to quiz. I got off on a question there. Let's see. The average on the quizzes is 79. Pretty dang good. True. Yeah. Cadence. Christian. Denise. Everybody, right? Okay. So give me a second, I'll go through there. Let me know if you have questions from the quiz or from homework. Let's see here. Did I do the other one? Yeah. So it's over there. Let's see what's going on. So any questions from that quiz? While I'm trying to figure out how to set this up the nicest way. All right, this will work. Yeah, I like this. All right, so real quick. Okay, we haven't really done this yet. I don't really necessarily like this formulation, but it's good to see all the values straight up. So let's see if everybody remembers how this works. We just talked about sine at 0 degrees or 0 radians, right? These are rads. What is sine? At 0. 0. I love it. Why? Because sine likes y, and there is no y when I'm just sitting on the x-axis. I really want that to make all the sense in the world. Sine is related to how big the y side of the triangle is. Well, if I'm on the x-axis, there is no y side. So that's 0. And then what happens to sine when you get to pi over 6? What's pi over 6 again, degrees? 30 degrees. So sine gets a little bigger, right? Because at 0, there is no y piece, but at 30 degrees, there is a y piece. But it's not very big, because it just got a little bit away from 0. It's just starting to grow. Poor little dude. How big is it now? 1/2. It's the smallest one. 1/2. Now let it get to pi over 4. Now it's a little bigger. Yes, the y piece is bigger at pi over 4. It's a bigger y piece. So what is it now? Rad 2 over 2. Let me put next to this. This is 30 degrees. What's pi over 4? 45 degrees. Pi over 3 is 60, and pi over 2 is 90. So what's it get up to at 60 degrees? Sine of pi over 3. Now it's pretty dang big. What's the only other value left? Rad 3 over 2. And then it finally gets to 90. That's where it's really happy. The whole damn thing is y. And just to really make sure you understand, how big is the whole damn thing? 1, because the radius is 1 in the unit circle. So now, what's sine of 90 degrees, or pi over 2? It's going to be 1. And just to remind you, rad 0 over 2, rad 1 over 2, rad 2 over 2, rad 3 over 2, rad 4 over 2. It's a beautiful pattern. Cosine, does this make sense? Cosine does the exact opposite. It's happiest here. It likes x. It's all x here. So what's cosine of 0? 1. It loves it there. It's all x, right? Then I lift up a little bit. Didn't the x get smaller? Aw. So it just does the same thing, just backwards. So what is it at pi over 6? It started off at 1. Now it shrank a little bit. At 45 is where they're both the same, right? 45-degree right triangle is an isosceles triangle, yes? If I have a 45-degree angle here, and this is 90, what must this be? 45. It's an isosceles triangle. So that both sides have to be the same length. So 45 degrees, pi over 4 radians, is where sine and cosine agree. It's where they're the same. So it's rad 2 over 2. So do you see how cosine's doing what sine did in the reverse order? So what's cosine of 60? Because now I'm really far away from the x-axis. I'm way up there. It's really scared. And then, of course, when I get to 90, 0, because there's no x piece at 90. At 90 degrees, it's all y. There's no x piece. So let me say this. Can you imagine if I draw this, and let's say at 30 degrees, right? I'm at 30 degrees. This is 1. I'm at 30 degrees. Can you imagine a flashlight? Really? Oh, that's horrible, Jeff. Let me just do this. A light up here. Can you imagine the shadow it casts on the x-axis? That is the cosine. So the shadow it casts on the x-axis is the cosine. So as it goes further up, the shadow it's going to cast on the x-axis gets smaller. And you see that here. It gets smaller, smaller, smaller. When I'm straight up and down, have you ever been in an area where something didn't cast a shadow at all at a certain time of the day because the sun was straight overhead? No shadow, right? So that's exactly here. Sun is straight overhead, no shadow. Okay, maybe. Now, can somebody tell me what's the idea behind tangent? What is it built on? What's the basic idea of tangent? What ratio? Y to x. Which is sine over cosine. And just to really prove that, what's sine again? Sine is y over h. And what's cosine? X over h. Do you see how the over h's would cancel? So you get y over x. So tangent, theta, is sine theta over cosine theta. So what's tangent right here? Yes, sine theta divided by cosine theta, 0. Okay, somebody else tell me here what's going to be. It's sine theta divided by cosine theta. Say again. Careful. No? What cancels? The 2's cancel, right? The over 2's cancel. So I get 1 over rad 3. What do you have to do to that? Rationalize it, right? So again, the whole idea behind rationalization is I can't do the square root of the bottom because there's only 1 3. Square root needs 2 things, yes? I could do the square root of 25 because 25 has 2 5s. So what I do is I give it another 3 in the radical. Then I get square root of 3 over 3. What's beautiful about 45 degrees? What's the tangent going to be? 1. What about at 60 degrees? Rad 3, because the over 2's would cancel. And what's weird at 90 degrees? You can do it. Can you do it? Maybe you can do it. Well, again, what's tangent? Sine divided by cosine. So what's 1 divided by 0? What do we call it? Undefined. It's just undefined there. Just gets really big as we approach the y-axis. Maybe. These are the values you must memorize. These are the voyages of knowledge. What do I do if I'm in a different quadrant? Right? So for example, what if I ask you, what is the cosine of, what do you got here? 135 degrees. And let's assume you have these memorized. I don't memorize these. You can if you want to. I just create these as I need them because I know these. So you need to somehow be able to call these up in your head. We will have a portion of the next test where you're not allowed to use a calculator.
Yay, Jeff, it sounds great.
Right. So you have to memorize these. You have to know these. Again, I highly recommend you don't memorize them necessarily. What's a really good idea to do when I'm faced with this problem? Can anyone tell me?
Break it down.
Okay, break it down. But the very first thing I should do, draw it. I love it. Where is 135 degrees? Second quadrant. How far away from 180 am I? Why is that special? What am I trying to figure out now if I say how far away from the x-axis am I? That is the, I think, reference angle, right? That's the reference angle. Stay with me now. We could do this. So how far away? If I go 135 degrees, how much further did I need to go all the way to 180? 45 degrees. That's the reference angle. So cosine of 135, and I think this is what you meant by break it down. Is it going to be positive or negative?
Negative.
Why?
On the second quadrant.
Cosine likes x, and what's x where I am? X is negative, correct? You can see that. It's that simple. It's that simple. Cosine likes x. I'm in a place where x is negative. Cosine's going to be negative. So cosine of 135 is negative cosine of 45. And I've got this shit memorized. So I don't care what angle you give me, Jeff. I'm just going to draw that shit, figure out the reference angle, figure out what sine it is, bam, I'm done. You can't do any of that if you don't have these memorized, right? So what's that? What's cosine of 45? Rad 2 over 2, 11. Okay, do you guys see that? So I know I've been throwing a lot at you. It needs to be thrown at you so I can kind of tie it back together, right? I just have to throw it at you and then kind of tie it back together. So here we are tying it all together. Okay. So here, you guys try this one. Tell me what the sine of, what do you got, Jeff? I don't know, buddy. Figure something out. 300 degrees. Don't say anything, just figure out what that is. Put it up here. So sine of 300. When I draw that, where am I?
No, fourth quadrant?
Fourth quadrant. Because I'm past 270, right? How shy of the x-axis am I? 60, because it's 360 total. Will sine be positive or negative there?
Negative.
Because it's where y is negative, sine likes y. Do you start to understand, if you know SOHCAHTOA, that doesn't do shit for you here. If you know sine likes y, cosine likes x, so much more makes sense. So let's see, this will be negative sine 60, and what's sine 60? We're at 3 over 2. Shebang. And again, how do if I get that 60 degrees, how do I know that's the bigger, do you guys understand that's the bigger option? 1/2, rad 2 over 2, rad 3 over 2. So when is it gonna be rad 3 over 2? When it's really close to where it likes it. 60 is really close to 90, sine's gonna be biggest, rad 3 over 2. It's negative because it's down. Maybe, okay? Maybe. So let me do this. Since this is all up here, this is perfect. Let's see. Yeah. I think this just goes back for a number of whiteboards. Okay. All right, let's do something exciting. All right, we're gonna. Guess what? What you guys tell me? Every time we learn a new function, what's one of the first things we do with it? Besides, how does it work with numbers? What's kind of the next thing we do? Graph, especially because we're in pre-calculus, and the whole purpose of pre-calc, for the most part, is how the shit do you graph things, right? So let's try to graph the sine function. Let's be careful about what kind of scale I want to use. I don't want to use 1, 2, 3, 4. That's silly, right? Now let's do this. Let's do it for a complete circle. So I want to go from 0 to what? 0 to 0 radians to 2 pi. Yeah, so I'm going to use radians because they're real, right? So I want to go up to 2 pi. Do you see how it makes sense to cut that in fourths? I'll show you, because I mean, if I cut that in half, what do I get? What's right in the middle? Pi. And what's right here? Pi over 2. And what's right there? What do you think? So pi over 2, 2 pi over 2, 3 pi over 2. You see what I just did? Right here, I've chosen each tick mark to be pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2.
Sure.
Okay. Stop for a minute. Okay, and tell me this. What's the biggest sine can be? 1, right? What's the smallest it could be? -1, right? Where's sine -1? Say again? 3 pi over 2, 270 degrees, right? Isn't sine -1 when it's down here at on the y-axis, right? Okay, so it can go from -1 up to 1. What is it at 0 radians? What's sine? 0. What about at pi over 2? 1. What about at pi? 0. Right? Is that everybody with me? Yes, sorry?
I didn't get that part.
What is happening?
I didn't get it.
Oh, all I'm doing. Okay. So are you cool with the scale we chose? Does that make sense? Because those inputs are easy to use. I don't want to use 1, 2, 3. I don't know what the sine of 3 is. Okay. What is the sine of pi over 2? What is it? What's the sine of 90 degrees? 1. Okay. What's the sine of 180 degrees? Where am I at now? I'm back on the, from your perspective, yeah. Where am I? At 180 degrees. At 90 degrees, I'm here. At 180 degrees, I am here, right, on the x-axis. So what's sine going to be there? It's all x, no y. So it's going to be 0 again. Cool? All right, maybe. And then at 3 pi over 2, like we discussed, when I get here, what's sine going to be? -1. And then when you get back to 2 pi, sine is 0. And then the whole thing repeats forever. Forever and ever and ever. You can kind of feel some stuff in the middle. Like at pi over 6, it's supposed to be 1/2. And at pi over 4, it's supposed to be rad 2 over 2, which is like 0.7. So, but we basically have the shape of it. My scale just kind of sucks a little bit. Keeps going forever, keeps going forever. So you've all seen this shape. You've all seen this. Very often it's in the background of a sci-fi or horror movie on an oscilloscope. Right? If anyone's ever done any sound, anything, you've seen the sine wave, the sound wave, the frequency? Okay. Increase the frequency and it goes, it gets really, right? Maybe. You turn up the volume, it gets larger, right? Okay. All right. So that's what sine looks like. This is what sine looks like. I didn't really make it through there, but I'll. What do you think cosine's going to look like? Not really flip it. What is cosine at 0? 1. Cosine of 0 is 1, yes? What's cosine of pi over 2? 0. Right, so cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi. What's cosine of pi? It's all x, so what's cosine there? -1. It's the full thing. It's all cosine. Right? It's all x. So at, where am I? At pi, it's -1. 3 pi over 2, what is it here? Cosine likes x, so what is it at this point? Is there any x piece to this? It's all y, right? So it's 0 again. And then at 2 pi, it's going to be 1 again. So it goes like this. Aren't they the same shape? Do you not agree with me they're the same shape? Isn't this purple line, isn't it just this line shifted? Do you guys see that? If I just took the blue line and I shifted it back a certain amount, in fact, how much back would I shift it so it would be perfectly on the purple line? How much would I shift it by? 5 or 2. 11. So cosine of theta plus pi over 2 is the same thing as sine theta. So if I shift cosine back pi over 2, it becomes, did I get that the right way? No, Joe. Good job, buddy. Read your own graph. So if I take the blue line, which is sine, and I shift it back pi over 2, it becomes cosine. That's better. Now the way you see it most often is this. This is a little bit trippy. This is just true just from our picture, right? If I take the blue line and then take it back pi over 2, right? That's to the left pi over 2, old shit, transformations. It becomes the purple, right? But you normally see it like this. Let's see if you guys are cool with this. Sine of pi over 2 minus theta is cosine theta. And cosine of pi over 2 minus theta is sine theta. So if I flip sine and then I move it pi over 2, it'll match up with the purple again. So these are, and in fact you can see that here real quick. What's the sine of pi over 6? It's 1/2. What's the cosine of, so that's the sine of 30 degrees. What's the cosine of 90 minus 30? What's the cosine of 60? 1/2, right? So we already knew that. They're off by 90 somehow, right? Okay. So let me do this. Let me give you, well, let's talk a little bit more here. I might as well. All right, let me do this. Let me draw this picture a little bit better so I can work with it some more. Let me just take sine. I'm going to draw sine very quickly and sort of a little bit less huge. I'm going to go backwards a little bit too. So sine is here, and then it's here, and if I go backwards, sine will be -1, because now I'm on the right. If I go backwards 90, sine is -1. I'm down there, right? So sine is -1 here. 0 here, it'll be 0 here. It's -1 here, so it'll be +1 there, and it's 0 again there. So this is a bit more complete. Not really complete because it does this forever. Now, watch this. Okay, this is where things get freaky. And you're all like, no, you're a little late with that shit. Can somebody remind me what the reciprocal function of sine is? What's 1 over sine? What do we call that? It's one of the other 3 trig functions, right? We're focusing on sine, cosine, and tangent because the other 3, once I know those, I just turn them over, right? But what are the other 3 trig functions? Cosecant? Cotangent? Secant. Which one goes with sine? Cosecant. It's 1 over sine. Man, I really missed the mark there. It's gonna bug me. Okay. It's 1 divided by sine, correct? Cosecant is 1 divided by sine. Okay. What, for cosecant, what can sine not be? What happens when sine equals some certain number? What's a bad number for sine theta to be? 0. When is sine theta 0? At 0, at pi, at all the multiples of pi. Do you see that? Every multiple of pi, sine is 0. Do you guys understand what I mean? 2 pi, 3 pi, 4 pi, negative 2 pi, negative pi, negative 7 pi. It's going to be 0 at all those, because that's going to be on the x-axis, just rotating on the x-axis. Okay. So wherever sine is 0, there's going to be a vertical asymptote. Remember, vertical asymptotes come from what's not allowed in the domain. When is the bottom 0? For cosecant, it's 0 and sine 0. Sine is 0 at 0 and pi and so forth. So there's going to be vertical asymptotes. Now watch this. I really want this to be nice and easy. I want everything to be easy. If you can graph sine, and sine is still new to us, but it's one of the easier graphs to make. You can graph sine. You can put cosecant very easy. Cosecant is 1 divided by sine. So what is the value of sine right there? 1. So what's 1 divided by 1? 1. What's 1 divided by like a half? What's 1 divided by a half? 1 divided by 1/2 is 1 times 2. 2. So it's 2 there. It's also going to be 2 here, isn't it? It's going to look like, let me draw this a little better. So it's going to be like 2 here, 2 there. So it's going to look like this. As sine gets smaller, 1 over sine gets bigger. Is that cool? What's 1 divided by 0.1? That's 1 divided by 1/10. That is 10. So at some point, the output of sine is 0.1. So the output of cosecant will be 1 divided by that will be 10. Way the hell up there. Way the hell up there. So what do you think is going to happen here? What is it right here? So it's -1, right? So cosecant is 1 divided by -1. It's also -1. Here it's -1/10. So cosecant will be 1 divided by, it will be -10, right? So it's just going to have the same picture, just opening down this time. And then it does that forever in both directions. So we expect cosecant to have some problems. We expect cosecant's graph to be gross because it's 1 over sine, and sine is 0 sometimes. So of course cosecant's going to have some problems. Poor little dude. All right, so I think I can give this to you now. Yeah, we got to do tangents still. That's okay. I want to give you a nice little, can you do my cake back there? A little bit fuzzy. Sorry about that, but I'm not really where I need to be. Keep this. So I just want you to have this, and just to kind of show you, this is just a reference guide. You will not be allowed to use this on a quiz or a test, so don't get overly excited. Just to make sure we can all see what this is trying to say. Oh. please to God, again, please to God, do not memorize this unit circle, right? This is just here to be a quick reference for you. As you're doing the homework, you gotta get this in your head, but for example, this is loaded with stuff. 210 degrees is the same as 7 pi over 6 radians. So it's got like all the degrees and all their associated radians, right? So my hope is as you do more and more homework, some of this stuff kind of sticks in your head, okay? It also has, like, what the hell's up with this, right? So this is a point. Isn't there a point on the unit circle right there, right? And this is what's the reference angle here? What's the reference angle here? 30, right? It's 30 away from 180. So the cosine of it should be big, which means the x part should be big, and the sine is small. So the sine part the y part is small. So that's what each of these points means. This is the cosine, because cosine is x. This is the sine is y. And again, I don't have to divide by hypotenuse, because the hypotenuse here is 1. Isn't the radius always 1 all the way around? Okay. Maybe. So if I gave you this and I said, what is the cosine of 300 degrees? Could you just look at it and tell me? What's the cosine of 300 degrees? Find 300 degrees. And what's the x piece? Because cosine is x, right? So what is cosine of 300? 1/2. You guys see that? So again, you have to memorize this stuff, but I want you to have this so you can kind of look at it to help you get this in your head. Okay. I've also got the basic definitions to remind you about up there. I've got this thing here, tangent is sine over cosine. Cotangent is x over y, so it's cosine over sine. I've got the reciprocal stuff. Blah, blah, blah. And of course I got the graphs, the basic graphs of each. There's sine. Cosine is just shifted over. See, its hump happens here, and this guy's hump happens there. And then these are the little u dudes we just did. There's, this should be cosecant. So that is? Yes. Secant. Tangent we didn't do yet. That's my fault. But why does it make sense that tangent's got some asymptotes? Because what's on the bottom of tangent? What's tangent equal to? Which trig functions? Blah over blah. Sine over cosine, right? So where will tangent have some issues? Wherever cosine is 0, right? Because tangent is sine divided by cosine. So wherever cosine is 0, there will be a wall, vertical asymptote. Okay, maybe. Okay, so let's focus on that for a minute. Of course, you guys all missed that. Whoever's at home, sorry, you're all sick and stuff. But there, it's a sheet. Blah blah blah. Okay, let's do tangent real quick. Tangent's going to be relatively easy. Did I put f of x and then put a theta, Jeff, earlier? No, I put x. It's okay, good. You put a little theta, dude. So this is sine over cosine. Can somebody tell me where it's going to have, we just said it. Sine over cosine. Where is it going to have vertical asymptotes? When is cosine 0? Give me one place cosine is 0. Where's cosine 0? 90 degrees, right? Pi over 2. Because no x there, it's all y. So cosine doesn't like it there. Cosine likes x. So there's a vertical asymptote at pi over 2. In fact, there's a vertical asymptote at every kind of odd multiple of pi over 2, including the negatives. Forever and ever and ever and ever, right? All the pi over 2's suck for tangent because that's where cosine is 0, right? And that's why there's a bunch of walls on the tangent. So let's do from negative pi over 2 to pi over 2. So there's a wall here, because that makes the bottom 0, and we know that's where vertical asymptotes go. And there's a wall here, same reason. What's tangent of 0? Remember, it's sine over cosine, so what's sine of 0? 1, no, what's sine of 0? 0, right? Sine doesn't like x, and there's nothing but x over here. So at 0, it's 0 divided by 1, so tangent of 0 is 0. Now, one of your favorite angles for tangent will be 45 degrees, pi over 4. Does somebody remember what's nice about pi over 4? That's where sine and cosine are the same, since tangent is sine divided by cosine, and they're the same. What's tangent at 45 degree angles? 1. Or negative 1, right? Depending on what quadrant. So in the first quadrant, sine and cosine are positive, so it's 1 here. But back here, where's negative pi over 4? Which quadrant? If I start at 0 and I go back pi over 4, where am I? Which one, sorry? No, if I only go back pi over 4, I can't get all the way over there. If I only go back pi over 4, I'm in the fourth quadrant, right? I only went 45 degrees back, so I'm just in the fourth quadrant. But what's true about sine and cosine? Do they have the same SIGN? Do they have the same sign? What's cosine in the fourth quadrant? Cosine likes x, so it's positive. What's sine in the fourth quadrant? Negative. Sine likes y, so it's negative. Do you guys understand why it's better? Cosine likes x, sine likes y. Helps you with so much more stuff. I'm not saying SOHCAHTOA has no use, but it has very little use. That's all I'm saying. Okay. So back here, tangent is going to be negative because sine is negative and cosine is positive. So it's going to be negative 1. So do you see how it kind of looks like a cubic dude? You see that? It kind of looks like a cubic dude. It goes here, and then it goes through 0, and then it goes up, and it's got to go up against these walls. And it keeps repeating, because I can rotate, I can go all the way around a circle however many times I want to. So up here, it's just going to look like this again. And it's going to look like this again. And over here, it's going to look like this again. Forever, in both directions. Forever, forever. Because I can rotate, 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 rotate. Okay, maybe. Okay. Let me ask you something. Look at this blue. The blue. Look at the sign here. Can you guys see how this is definitely something, and it's going to be repeated forever, right? So once I've done this once, I can basically do that forever. And then it does this. It goes down and up. Isn't this plus this everything it ever does? Do you guys agree with me? This and this. That's all it ever does. This and this. Okay. How long does it take it to go through one complete picture? We call it a cycle. So a cycle just means how long does it take it to get through one complete piece of itself? How long does it take? 2 pi. How long does tangent take? From negative pi over 2 to pi over 2, how far apart is that? A full pi, right? So what we call that, the length it takes for it to get through one cycle, we call that the period of the thing. All right, so this is the period of tangent. Spell correctly, Jeff. That'd be great. Period of tangent is pi, and the period of sine and cosine, well, it's actually sine, cosine, cosecant, and secant is 2 pi. So the period of tangent and cotangent is pi. That's going to become very important later. I think that's also on this paper, right? Yes, look at me. Look at me go. So it's also on this little paper. Okay, all right. And it's a lot. I know it's a lot. But it all is connected. All right, once you understand a piece of it, the other piece just immediately makes sense, is what I'm hoping. Right? They're all connected. Okay. So can you imagine, we're not going to do this today. We got other stuff we're going to do today. But do you understand that the next thing we're going to do is to start shifting this around, right? We're going to squish it, and it's going to make more sense. A sine graph looks like a spring. So when I squish it, it actually makes physical sense. I'm squishing the spring. I'm stretching the spring. So trig functions are cool with compressions and stretches. They actually make sense. They're like springs. Okay, maybe. So, enough with the graphing for the moment. I just wanted to kind of lay that groundwork. Oh yeah, there's this guy. Okay, so, yeah, let's do this. Yeah, we can do all of these. Okay. Oh man. So I got a little handout here. Sure. Okay, so I've decided just now I'm going to really ruin your days. Let's see, 2, 4, 6, 8, 10, 12, 14. Oh, that's perfect. 16. Let's see. Sort of perfect. Yeah, why not? Okay. All right. Okay. You'll love this shit. You ready? You know what I'm about to do. 1, 2, 3, 4. So far, so good? 1, 2, 3, 4. Yes? 1, Mohammed. 2, Prince. 3, Nat. 4, Ivan. 1, 2, 3, 4. Find your groups. 1s work together, 2s work together, 3s work together, 4s work together. Yeah! Sorry.